Check, check, check. Okay. Today, first trial only, the cursor is moving, the indicator is moving. Yes. So, yeah. So we meet again after the Shera. I think one more class we have. So we are continuing with the practice. I have included some more material. Uh, Pie chart, I couldn't find good material in Khan Academy. Mostly they are Khan Academy material. So for pie chart, we have a different source, which is also a very good source. Yeah, it's, the name is Head Bullseye. So all these material what we using now will also help you in different competitive exams. Yeah, like CAT, especially MBA exams, MBA entrance exams, and other different kinds of exams where quantitative aptitude is there. Yes. So, so make sure the concept is clear. You can actually watch a couple of TED talks by the founder of Khan Academy, which whose name is also Salman Khan, not the Salman Khan actor, but he is a different Salman Khan. Yeah, much probably much more useful for us. Yeah. So you can watch those videos, how it started and everything. And what are the principles behind this portal. So it is designed in a way that you get enough chance to complete 100% of the prerequisites. Yeah. So, like if you want to study calculus later or complicated statistics later, this portal will give you enough opportunity to clarify the basics, 100% basics. Usually, what happens, like what we are doing right now, also, the criteria is what the passing criteria is very less. So, somebody who has scored, say, 60%, 70%, 80%, and 20% actually he doesn't know. Somebody who has scored 80%, that roughly means 20% of the concept it is not very clear as of now. So still he will move on to the next course, and he will forget about this course. Yeah, that 20% will be left forever. But this portal is designed in such a way that you get enough chance to fulfill 100% of the prerequisites. Yeah. So that is why it is so nice and so popular. Yeah. So we will have a few more games. So dispersion also, uh, I think standard deviation practice we did a little bit, or only mean median mode we did till now. Standard deviation also we had started, right? Okay, okay. So I have shared the screen. Yes. So here, for a moment, ignore these numbers. So these are two data sets. Two data sets. Okay. So all the values are there on the x-axis, and these dot represent frequency. How many people, how many data points are there with this value, this value here. I'm moving the cursor. I hope it is visible. Might be some lag, but we can work around it. So how many data points are there with this value? Then how many data points are there with this value? With these three dots. How many data points are there with these value, this value on the x-axis? So the frequency is denoted here by 6 dots. Okay. So let each number of dots represent frequency, and the values of the variable, whichever variable we are measuring, is on the x-axis. Similarly, the other graph also. Okay. So, looking at this figure, in which data set would you say the data is more spread out? किस डेटा सेट में, किस ग्रुप ऑफ डेटा में डेटा बहुत फैला हुआ है, डेटा बहुत फैला हुआ है? So take half a minute and write. Yes. Anybody wants to give an answer? Attempt an answer. You understood the question first of all. Yes. How many understood the question? Okay. Second. Yes, definitely. Second is the right answer. Yeah. So you can see here, data is more spread out. Pictorially also you can see. And when we actually calculate the standard deviation, we see that the standard deviation of the second figure is higher. So that means data is more spread out in the second data set. Again, for practice, just have a look. Okay. Now everybody should be able to answer. Yes. Look at these two. check, 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 check. Am I audible now? Now it is
Yes,
moving, I
sir.
guess. Yes. Yeah. So yes. So in this, the data set A is more distributed. Now, if we calculate the standard deviation, we will see that in the data set A, we have a higher standard deviation. Okay. So you now know what is meant by dispersion. Yeah, dispersion is how spread out the data is. Data kitna phaila hua hai. That is meant by that is what dispersion means. Dispersion means. So measures of dispersion, standard deviation is one good measure. That is the most robust measure is standard deviation. Okay. So okay, so you can check also. You can, yeah, correct. So everybody knows how to calculate the standard deviation step by step. किसी को अभी भी summation sign देख के कोई confusion तो नहीं हो रहा है. So this is the formula to calculate standard deviation. In effect, what we are doing, we are calculating the difference between mean. First, we are calculating this mean mu. Yeah, जो ये figure है, ये जो figure है mu, that we are calculating first, and then seeing how each data point, how much each data point is different from mu. How much each data point is far from the mean. We are taking those differences, squaring them, and adding all those squares. Yeah, that is what is meant by summation. Adding all those squares, then dividing by n. That gives us the variance. Now we want something in the units of the original variable. Yeah. So we take a square root of the variance and get the standard deviation. Standard deviation is in the same units as the variable. Whichever variable we are considering, height, weight, temperature, whichever variable we are considering, standard deviation will be in the same units. Variance units sometimes will mean something, sometimes it may not mean anything. Yeah. Like in temperature, variances unit will be temperature square, which does not mean anything. But if it is length and we are measuring length centimeter, variances unit will be centimeter square, which has a meaning. So unit of area can be centimeter square. Okay. So keep that in mind. We step by step we will calculate standard deviation. These are all the steps. Let's go to a problem directly. Yeah. So this is this very small data set 6231. Yeah. So we want to calculate standard deviation of this data set. One more thing, remember that these measures cannot be for one data point. We cannot take one data point, just say 10, and try to calculate its standard deviation. That, of course, does not mean anything. That should be clear to you. Yeah. So only when we have a data set, yeah, couple of numbers, then we can do all this. We can try to calculate the mean. We can try to calculate the standard deviation. Which why we are doing all this is because we want to represent this data set, which includes not many numbers, by few simple numbers. If it is already one number only, then we do not have to do anything to represent that with a different number. So here our target is to represent this set of data with few simple numbers, mean, standard deviation. So, how do we calculate the standard deviation of this? 6231. Very simple. I'll open the whiteboard. I hope it will work. One of the classes it was not working. Oh, okay. So, uh, I think my computer really likes your patch. Let's see if I do this. Still it works. But what had happened in the other class? So 6231. 6231. First step is what we will do. We will sum these. So 8, 11, 12. This is the total. Then we take the mean, arithmetic mean or average. That will be 12 divided by how many numbers are there? 1, 2, 3. This gives us 3. So mean here is 3. Mean you can represent by mu or say x bar. Mu or x bar. When we think that we have included all the numbers, these are all the numbers possible in some instance, then we use mu. When all the numbers have been included, we call it a population. Population. When only a small group of numbers from the entire population is included, we call that small group a sample. In that case, if it is a sample, we use this notation x bar. And when we can confidently say that we have included all the numbers, we call it a population. And then the mean is denoted by this mu. Okay, that is the difference. There is no reason to get confused between these two. Yeah. So yes, so now mean we have. It helps if we use tables to calculate standard deviation. I mean, draw a table to calculate standard deviation. These variable we can denote by x. Then we will take, say we have taken a small sample, so we call it x bar. So we will have x minus x bar column. You can also write xi to denote that this I will be changing. So this is x1, this is x2, the number 2 is x2, this is x3, this 1 is x4, like this. Many times it is useful, that is why we put the small I, subscript I here. Yeah. So this is xi minus x1. So here the number is 6, the mean is 3. So xi minus x bar will be how much? Xi minus x bar will be how much? For this here. Yeah. I'm not drawing a zero. drawing a blank space.
3.
3. Yes, 6 minus 3. That is 3. So similarly here it will be minus 1, 2 minus 3 will be minus 1. Here it will be 0 and here it will be minus 2. Yeah. Now in the formula we need this xi minus x bar square. Remember the formula for standard deviation. So square is there. Xi x minus x bar whole square. So that also we can easily calculate if we draw a table like this. So square of 3 will be 9. Square of minus 1 will be 1. Square of 0 will be 0. Square of minus 2 will be 4. Okay. So now we need summation of all these xi minus x bar. Again, going back to the formula, summation of all these square terms. So we will sum this up. So 9 plus 10, 20. So summation is done. Now what else is there in the formula? Divided by this n minus 1 we can ignore, as I also mentioned earlier. It is due to a concept called as degrees of freedom. So many times the denominator will be smaller than expected or than discussed so far. So the reason is we are trying to account for degrees of freedom in the sense we are fixing some value while calculating these numbers, these measures. We are knowingly or unknowingly fixing some value in the original data. So those values cannot change. Other values can change. Still, we will have that measure, but one value or two values will become fixed when we try to calculate these measures like standard deviation and other such measures. So to account for that, we uh, increase the denominator little. We decrease the denominator a little bit so that the value of that measure becomes a little higher. So that concept we can discuss later when say time comes or when you are interested. We can have a special session on degrees of freedom. I can also provide some material for you to have a look on some good videos also watch in your free time if you're interested. So you can ignore this minus 1. So it is divided by n. Yeah. So variance will be this 14 sum divided by the number of variables, that is again. So 14 divided by 4 will be 3.5. Is it correct?
Yes, sir.
So variance is this. Now this is not complete yet. So standard deviation is square root of these variance, square root of 3.5. So standard deviation, which we denote by a symbol, which is called sigma. Sigma. That is. So root over, there is a process to find out root overs. As such, also we know that it will be somewhere around 2. So square root of 4 will be 2. So it will be less than, slightly less than 2. Or we can use Excel calculation. Excel as a function. Actually, when you find time, you also revise how to find square root. Yeah, it is a simple division-like method. Yeah. You group two numbers and divide in a special way. Yeah, do a division in a special way and get the square root. Because one might think that why we are using Excel all of a sudden when we are doing rest of the things by hand. So you can also use you can also find out square root by hand. Here it is 1.87, 1.87. So standard deviation is 1.87. Okay. So this is the process of finding out standard deviation. Standard deviation. And it gives an estimate, a measure of how spread out is the data. Spread out is the data. It is a measure of. Now you know how to compare standard deviations. So when standard deviation is high, the data is more spread out. When it is low, the data is concentrated. Where it is concentrated, not randomly anywhere, it is concentrated near the mean. It is very important. When standard deviation is low, it means all the data points are concentrated near the mean. So the standard deviation we are considering with respect to the mean here. Expand with respect to the mean. So this is mode standard deviation. You can do more problems. The link is given. Yeah. Let us check if we did everything. So our mu was this is the mean. The mean we found was 3. Mean we found was 3. So we can put 3. We can check. Yes, that was correct. So why I am showing this is when you try on your own, you will also get this enriching feedback. Yeah, encouraging feedback. यहाँ पे आप एंट्री करोगे अपना आंसर फिर चेक करोगे यहाँ पे आपको राइट मिलेगा या रॉन्ग मिलेगा रॉन्ग मिलेगा तो आप एक्सप्लेनेशन पे जाके देख सकते हो आपने क्या किया है if you have done something different. Then the next step was to find out the difference of each of these numbers and square those differences. So here, with respect to 6, the difference was 3. It is squared as 9. With respect to 2, the difference was 1, minus 1 actually. The square was 1. 3, it was 0. 1, the difference was minus 2. And that square of that was 4. Check is all the values entered are correct. Suppose if we enter a wrong value, it will, then you can click on explain. Yeah. If you all the answers, then you can check. Okay, then what did we do? We summed it up. That is what is meant by the summation, and our sum came out to be 2p. Sum of all these square of differences came out to be 2p. Let's see if that was correct. Yes, that was also correct. Then we took an average. Yeah, so that came out to be 2 divided by 2. That is 3.5. Yes, that is also correct. Now the final step, taking square root of that, and we calculated approximately it is around 1.87. Yes. So finally, we calculated the standard deviation of this data set. Which data set? This small data set, 6231. Yeah. As 1.87. 1.87. So I hope calculation of standard deviation nobody will forget for your life, 70, 80, 90 years, whatever it may be. I hope it is longer and we do many more things, many more good things. So standard deviation, you practice standard deviation. There is more practice of standard deviation you can check out. Let us see some graphs. I think graphs have been ignored till now in practice. So let us see graphs. Box plot. We will also see box plot. Let us start with all these links are shared via TCS, the updated links. I hope you received a message today, a couple of hours back. Yeah. Yes. So this is the first question. The pie chart given below shows the spending of a family on different articles for the year 2000. Analyze the pie chart and answer the questions which follow. So you can see this pie chart. Have a look at this pie chart, or maybe take a screenshot of this pie chart. All right. So let us see what they are asking. What is being asked? If the total amount that was spent in the year 2000 was 50,000, the amount that was spent on food was how much? Yeah. So yes. So these are not very obvious option. Yeah. So we have to calculate first. The total amount spent was 50. The amount spent on food was how much? So the total of this whole pie is 50,000. Food was 45% of that. So the amount spent on food was 45% of 50,000. So 45%. So this is the let's, okay, let us check. Before taking, we should check. But sure the values that is given like in Anakil. Okay. Yes, so it is 22,500. So now you can take or say double tick green color. Yeah. Now you do one. The total amount that was spent in the year 2000 was 48,000. The amount that was spent on housing and clothing combined was 4 lakhs. So we are talking about housing and clothing combined. Just make a note of that. Total amount is 48,000, and we want to find out housing and clothing combined. I will let me see something to project the pie also. Yes, this is a almost perfect view. So you do this, I'll close my audio. Yeah. So you have 2 minutes to figure this out, to solve this. Yes. So, sorry, I had to move away from the desk for a couple of minutes. Uh, okay, 9,600. One of you has said, and quartiles, deciles, and percentiles. Okay, let us see the answer. Yes, 9,600. Okay, quartiles. Oh, yes, quartiles. Perfect. Practice I have practiced. So, just a second. Uh, Try one more pie chart problem, or you want to try histogram problem. These were actually uh, the so-called level one problems in pie chart. You can have uh, more complicated in the sense they will have incomplete information. Then yeah, you will have to calculate based on that incomplete information. So that makes things complicated actually. So this is one problem in histogram. Following data points represent the final exam scores for each student. Using the data, create a histogram. Okay. So they have already done a part of the work. Actually, choosing the scale on x-axis and y-axis is the first step you will be doing. They have done part of it. So you have to create a histogram. So try this. I'll get some problems on percentiles and quartiles. Decile is actually percentile only. So percentile and quartile. Just give me 2 minutes. Okay. I hope you are able to see the screen. Are you able to see the screen?
Yes, sir.
Okay.
Yes,
Okay.
sir.
Okay. So we will solve this. We will solve this problem. First, let us see how your histogram came out to be. Yeah. Second, share screen. Yes. So anybody who would like to share their screen can do so. So tell me if I'm doing right. So, the data points represent the final exam scores for each student in Sarma's first period class. So how many students are there? 3, 6, 8. 8 students are there, and uh, we will be representing the scores here. So between 60 to 80, how many students are there? Yeah, so let us look at the lowest number, that is 57. So between 40 to 60 is the first number which falls, the first number in this group is between 40 to 60, and this class interval, so to say. So it is only one. So we will put a bar which ends at 1 here. These on y-axis, these are all frequency. Then 60 to 80. Within 60 to 80, how many numbers are there? One is there, 69. Second is 72. There is one more 69, so that becomes 3. And yes, so 3. Okay, just check if I'm doing right or wrong. It will help if you arrange it in ascending order, and also start crossing out whichever number is over. So 69 is over, 72 is over, 57 is over, and then again 69 is over. Then the next range is between 80 to 100. How many numbers are there? 93 is there, first number. 83 is the second number. 84 is the third number. Then 92 is the fourth number. So in this range, we have 4 values. So our histogram will look like this. Many times we put a circle at the top end of each of the boxes, exactly at the center, yeah, and connect those points. That curve which we get by connecting the midpoint, top and midpoint of each of these bars, is called ogive. Ogive. Yeah. It will look something like this. So here we have these 3 bars. Yeah. So the midpoints we will take. This is the midpoint. This is the midpoint. This is the midpoint. So with a freehand curve, we will draw a curve like this. Yeah. So this curve is called ogive. This curve. So this is about histogram. Let us see if we have drawn it correctly. Okay, nice one. Okay, so histogram, one very simple example we drew. Yeah, there is nothing much to think about histogram. Just figuring out the scales. Yeah, figuring out the axis is 90% of the job. Then the rest is simply drawing the bars, which is very simple. Now let us come back to percentiles, which everybody wanted. Yes, have a look at this. Okay, I think time is over, and tomorrow do we have a session? Wednesday. No, tomorrow we do not have a session. Okay, do you have the next lecture, or is it free by any chance? Do you have the next lecture?
Yes, sir.
Okay,
Yes, sir.
okay. So let us quickly. Okay, note this down. Attempt it, and then yeah, I'll actually put this link. These are fortunately or unfortunately, I don't know, but these are solved examples. So you can check for each other. You can give each other some problem, one of the problems, and then verify if your friend has done it correctly. I have shared it with everyone. I have shared in the group percentile problems links. This is again a very good startup, very good uh, educational startup like Byju's. Yeah. So they refused to be taken over by Vedantu. They said it is we are too passionate about it, so, for that we sell it for money. So we won't be selling it to Byju's. Vedantu said, Vedantu founders said, yeah. So yeah, have a look at that link, and if you face any problem, you can send me an email with the screenshot. Yeah. So yes, so, actually nothing to be afraid of. All recording there, and my questions will be simple. Yeah. So try your best, and my best wishes are with you. Okay, for the midterm. All right then. See you on the other side of midterms.